Hello again. So the way I'm going to do this lesson is we're going to move to non-standard normal probability distributions. And what that means is the mean is no longer 0 and the standard deviation is no longer 1. So the mean and standard deviation can be anything, and that's a problem with how we've been tackling this. So I'm going to show you. First, we're going to use the calculator, because for the calculator it's very simple. I'll do at the tail end of the video how to do it from the table, because I don't think as many people are going to want to do that, but we will walk through it. Okay, so now what I've done, see, these are more realistic. Like when you're doing a real problem, meaning outside of this class, like in the real world, it's normally in some kind of everyday life context. So we're talking, I made an example of the average height of a person, let's say in like a certain building or something, is 65 inches. So that would be 5.5 feet. Actually, 60 inches is 5 foot. So this would be 5'5". That's what that is, 5'5". And the standard deviation is 4 inches. So the average or mean height of the person is 65 inches, and the standard deviation is 4 inches. So that gives us mu equals 65 and sigma is 4. So now we're going to answer these questions based on this. So if I want to know if the probability if the person is more than 6 foot, well, look, our units don't match, inches and feet. So 6 times 12, that's 72 inches. Now think about that. More than 72 inches. What does that look like? The mean is 65. 72 would be here, and I want to know how much are more, or how many are more than. So the 72 would be my low value. 9999, or infinity, would be my high value. And now I have these values for mu and sigma. So here we go. I'm turning on my calculator. Second distribution, option 2, normal CDF. Lower value is 6 foot, or 72 inches. The upper value is infinity, 99999. This time I got to put mu as 65 and sigma is 4. And when I press enter, I get point. Where can I put my answer? I didn't leave myself any room. Equals 0.040. So if this data was accurate, which it isn't, I just made it up, only 4% of the people would be over 6 feet tall, based on this mean and the standard deviation. Well, what's the probability that if I picked a person randomly, they'd be under 4'5"? Well, we got to convert that to inches. 4 times 12 plus 5. That would be 53 inches. And now we got to think about the scenario. Under or less than. So what does that picture look like? Here's mean, which is 65. 53 would be back here. And we're talking about under. So the low value would be negative infinity, and the high value would be this 53. So I'm going to type in second distribution, option 2. So my low value, negative 99999. My high value is 53. And I'm still using 65 and 4 for all these problems. So this would be 0.001. So 0.1% of all the people would be under 4'5" based on this information. Finally, between two values, well, 5 foot would be 60 inches. 5'6" would be 66 inches. So for this, my low value is 60. My high value is 66. my mean is 65 and the distribution is 4, or standard deviation is 4. Second distribution, CDF, 60, 66, 65, 4, and I get 49.493. So 49% of all the people would be between 5 foot and 5'6". Okay, so that's pretty straightforward, I think, I hope. How would I do this without a calculator? So to do that, let me clear some of this information. We've got to get z-scores to use that table. So I got to erase this. So mean, I'm going to just record mean is 65 and standard deviation sigma is 4. So to convert this to a z-score, which you would only do this if you're using a table, if you're using a calculator, you don't got to worry about any of this stuff. The z-score is going to be equal to x minus mu over sigma. So let's take this problem. More than 6 feet. See, we want a z-score here. If I can't just put 6 into my calculator, I have to make it a z-score. So this would be the x. The number, sorry, that's not a bar. The number we're interested in the particular problem is the x. So in this case, z would be 6 foot, which is 6 times 12, 72 inches, minus the mean, which was given as 65, divided by the standard deviation is 4. So it'd be 72 minus 65 equals over 4, 1.75. So that's a z-score of 1.75. So I could rewrite this problem as what's the probability that a z is more than 1.75. See, I changed from a person to z and from 72 inches to whatever that z-score was. And this is what we did in our first lesson. So I have to get my table. 1.75 is positive, so I find 1.7. I go over to the 5, and that is telling me 0.9599. So, oops. So my table is telling me, oh man, this is cluttered. On my table, I'm getting 0.9599. However, this is to the left, right? Correct? When I do this 1.75, that's the left-hand side, and this wants more than, so it's actually 1 minus 0.9599, which would be 0.0401. And I think that was what we had before, 4%. So it's harder. That's why everybody wants to use a calculator. And this is a part of the class where I kind of warned you, you're going to want a graphing calculator. Let's try the next one. I'll have a little more room. And this is under, so we could just use the value on the table. All right, so this is 4'8", which was 53 inches. Except I'm not using a calculator, so I got to go to z-score. So I want the probability of not a person, but the z-score is under or less than. So I got to find a z-score from these inches. So that would be 53 minus mu over sigma. Notice that this is going to be negative. So 53 minus 65 over 4. I get -3. So this is my z value of -3. So I got to go to the negative side. And -3, 0, says 0.00135. And it is under, so that would be my answer. And I believe that did match our calculator answer. Okay, third one. So probability that z is between, see now I got two things, 5 foot and 5'6". So remember, the pictures I think help out a lot. 5'6" is 66 inches. 5 foot is 60 inches. And the mean was at the 65. So in order to do this, we have to use the table value for this and take away the table value for that, and what's left will be the part we want right here. So I need a z-score for both of these values, and we got to keep track of what they mean. So this z-score is going to be 60 minus 65 over 4. And this z-score is going to be 66 minus 65 over 4. So this is between -1.25 and 0.25. So there's the problem we got to do. So 0.25 would be 0.5987. 50, that's 60%. And -1.25 is 0.1057. And the part that really confuses people is we got to know what to do with those numbers. We're taking this 60% and taking away this 11%, and what's left is the part in between. So our answer is going to be 5987 minus 0.1057, which looks like 0.4930. And that should match what our calculator told us. So that is harder. If you can use a calculator, I would use a calculator. If you have a different model that I didn't discuss and you can't find a YouTube video on your particular model, let me know and I'll see how I can help.